Okay, so yesterday I had recorded our class and the video, something like about a 30-minute video. I have posted it on YouTube on my channel. So I gave a link to that. Anybody wants to have a look at yesterday's class, you can have a look at it through this. So if you click on the link, it will directly take you to the to YouTube, I think, and you can watch the video. You can forward it in whichever section you are interested in, and wherever this is relevant, I will be posting the videos. Okay, so just in case somebody misses a class for whatever reason, because your internet wasn't working well, or you couldn't hear things properly, or you couldn't see things properly, there will be a recording which will be posted on a daily basis, so you can always catch up by looking at the video recording. Okay, so is that clear?
Yeah, sir.
Okay.
Yes.
Then I had I had posted a very simple problem which needed to be solved, which was given in this way. So this part of it is more or less I'm like giving some very simple tasks for you people to solve, because many of you are new to Google Classroom. Just to get you kind of familiar with the way in which we use this. The problem was a very straightforward problem. As I had mentioned over here, it's not the solution itself that is of significance. How you got to the solution, whether you are able to, just a moment, let me finish what I'm saying. Whether you are able to recognize the pattern in which you thought to solve the problem. Okay, typically problems like this, let me just open the PDF link. Typically problems like this, we don't actually use. Yes, is anybody waiting for waiting in the waiting? Yeah.
Sir,
Yes, Rajiv.
in my old school, I used to use Google Classroom.
Okay, Rajiv. I thought the way you were talking, I thought somebody was waiting in the waiting room. Okay. All, just mute yourselves, guys, so that you can hear what I. If you keep interrupting me, then it will be difficult for me to communicate with you. So speak only if you have to. Okay. So it's not so much the solution to this problem as I expected. Most of you were able to solve this problem very easily. But what I wanted you to do is to share a little bit about what pattern did you use to solve this solve this problem, if at all. That is, how did you think about this? Okay, and just like we did the dots pattern recognition work yesterday, you will be surprised that there are many different ways in which people look at this problem and solve it. So I am aware of three ways in which you can solve this problem, at least, but I'm interested to hear if there are any more. So could somebody share how they went about solving this problem?
Sir,
One or two of you had also written it down, but yes, yeah. Just speak, tell your name and speak.
the Daham, and I want to tell that my answer was and my pattern was pretty straightforward.
Yeah.
It was direct.
Direct.
222 divided by 2. I tried some other ways like 222 divided by 2 plus 2, 22. That gave 133. So that was not an option. But my first
that particular way of that particular thing that you said, I would like to talk a little bit about why that is not the correct answer. Why did you realize that when you did 222 divided by 2 plus 22, you got some answer, but why is that not the correct answer? Okay, so we'll chat about that a little later. Yeah, go ahead now.
Answer was, my pattern was direct. 222 plus 2 divided by 2. That's it.
222 plus 22 divided by 2, which will give you 244 divided by 2, which gives you an answer. Okay, fine. Anybody else would like to share their solution? Just tell your name and then say something. Yeah.
Sir, I did it with Godmaster.
Okay. Explain yourself.
So there were in BODMAS, first I have to solve the brackets. So first I solved the brackets, 222 plus 22. So the answer came as 244. Then I divided it by 2. Then I got the answer 122.
Okay. Yeah, most of you would have done this. Anybody who used paper, pen, and mass to solve this problem would have done that. And I'm going to just one moment. So I'm going to go ahead and call that as the boring solution. Okay, so that's the boring solution, just for fun. Somebody tell me if you used a non-boring solution, if you found some other way of solving it. Okay, so say your name and give your solution. Yes, somebody wanted to say something. So the moment I said boring solution, people, yeah, speak. Tell your name.
So, my name is Manu. So, do we have to submit this in the Google Classroom?
Yeah, you can you could have just written the answer as a comment and submitted it, but that's okay. It doesn't matter. It's such a small, straightforward problem. You don't actually have to answer it like in that way. You can answer it even now. Anybody else? Anybody else? So what I'm going to do is I'm going to. Sorry, I couldn't hear that. Okay, nobody else? Nobody else wants to share the solution? All right. So I'm just going to go off video mode now. I'm going to shift my camera to the whiteboard. So just give me 2 minutes. Meanwhile, maybe, yeah, okay, maybe what you can do is I'll give you a small task to do. You can look at that, this thing. Just a moment. Okay, while I set up the mic on the whiteboard and discuss the other solution, I just want you people to have a look at this. So this is a book that I found on a website, which I will talk about a little later. For students of any subject, but particularly of mathematics, I feel it's a very good thing for you to be doing a lot of parallel reading about the subject. Okay, so there are lots of very interesting, delightful books about mathematics. Unfortunately, many of them are not directly available to people, or in the sense that people don't usually read books about mathematics. Because that's for loony people who like mathematics, and weird people like that. Only they read books about mathematics. But there's a lot of nice, good books which have been written for people who also don't like mathematics. Okay, so I found one such book called the I Hate Mathematics book. So I have given a PDF copy of that over here. And like I said, this is only for those people who told me yesterday that they hate mathematics. And as I have written, the rest are forbidden to look unless you have decided to hate mathematics today. So wink, wink, nudge, nudge. So what I want you people to do is, right now, while I shift the camera, because I'm going to switch off the camera and then shift it, please go through the first few pages of this book at least. If you just click on the PDF, of course, the link opens up. So you don't have to, you won't be able to operate what I am trying to show over here. But you can always go to your Google Classroom directly with your browser, and then click on the PDF. The book will open, or download it and open it. And then just look through the first few pages of this. I'll give you a minute or two, and by the time I should have been able to set up my camera. Okay, is that fine? Is that clear? I can still hear you. So if you have something to ask, please ask.
Sir, we will not be able to change the pages because you are only in control.
That's what I'm saying. That's what I'm saying. You open the PDF in your own browser. Did you understand what I'm saying?
I opened it. Sir, for that you have to stop screen sharing. If you don't stop. No, we can do it like that also. I opened it.
No, not necessary. Not necessary. You can open your own browser, go to your email ID, log in, and then open Google Classroom. In fact, whenever we have maths class, keep your Google Classroom open and ready.
Sir.
Is that? Yeah. Go ahead. Do it. Don't keep.
Sir.
Don't keep asking. Yeah.
Sir.
Yes.
For that, if you want us to go out, you have to stop screen sharing. Then only we have the option to go out.
So incidentally, I'm just showing another book like the one over there. This is a little bigger book, and you have to read a lot more in this. But this is there in our library. Has anybody seen this book in our library? Alex's Adventures in Numberland. So this author, Velos, is a very interesting writer. He's what we call as a science communicator or maths communicator. There's a group of people now who are mathematicians, scientists, and so on. But they write very interesting books about the subject for children, anybody who's interested in the subject and wants to understand more. So I have been seeing this, but I've never read this book before. This is the first time I'm borrowing it for reading. There's another author that I like very much called Ian Stewart. I have read almost all the books of Ian Stewart that is there in our library, but I'm going to try and read this book. So I'm just emphasizing reading books on mathematics is very important for students of mathematics. Okay, so from the book I Hate Mathematics, one of the first tasks that I want you people to kind of look at, it's not a task, it's not a mathematical task, but basically they say if you have a rectangular surface, say, and you have one line that you can draw, in how many ways can you divide this rectangular surface, like a tile, say, for example, right?
1 million.
Yeah, so if you use one line like that, you can break it up into two parts. Okay, so you can say this is 1 and this is 2. Okay, now what if you have 2 lines? Then how many ways can you do the same thing? Okay, so if you have, yeah. So if you have two lines, then you can sort of do this, in which case you can have 3 parts. Okay,
So we can also have 4.
Yes, or you can also do this, right? And you can end up breaking it into 4 parts.
With only 2 lines.
With only 2 lines, yeah. These 2 are 2 lines. This is just 1 line. Now the question is, mathematics is all about patterns. Okay, so what you want to do is you want to do it with 3 lines now, and then you want to do it 4 lines. So the question is, how many minimum number of parts will you break any surface, right, if you use a given number of lines, and how many maximum such surfaces are possible for the same number of lines? So that is the first interesting task that has been given in that book, I Hate Mathematics. So if somebody tries that out and you find some pattern, I would like to hear about it in the next class. Okay, so I'll post this also as a question in the Google Classroom. I just want one help from you guys. When I start teaching, I lose track of time. So if somebody can keep track of time and just let me know 5 minutes before closing of class, that will be useful.
Okay,
can you do that? Who will do that?
Veer, sir.
You can't say me. You have to give your name.
Sir, Daham.
Sir, Veer.
Okay. Yeah, okay. So now I just want to discuss one thing about the problem that I had given. Okay, so I had given 222 plus 22 divided by 2 is equal to what? Okay, did that go out of your view? Are you able to see the whole thing? Are you able to see the whole thing?
sir.
Okay.
Yes, sir.
Sir, I can see the whole thing.
Good. If one or say I can see it, that's good enough for me. If somebody can't, then you have to say, okay. So now everybody doesn't need to say yes, I can say, yes, I can see. Okay. Now the way in which you would normally go about this is you do 222 plus 22, right? So you get 244, and then you divide that by 2, and this is, you can see very easily, 2 can be divided by 2, 4 and 4 can also be divided by 2, so you easily get the answer 122. Okay, now when I don't remember who was it, Nivan, who was sharing this solution, so he was saying an alternative solution. So he said, I tried doing this, I did 222 divided by 2 plus 22. That question can also be interpreted like this. So this is one way of solving it, but this is another way of looking at it. And I say, don't jump to conclusions about what is right and what is not. Try it out for yourself and then try to understand why is it that it does not work. So he said that, okay, then what you get 111 over here plus 22, and then you got 133 as the answer. Okay, now the point is that Nivan said that that's not on, or that's not correct, or that's not the way to go, something like that you said, right? Why did you say that? Why did you say that? It looks all right to me. So 222 divided by 2 is 111, and 111 plus 22 is 133. The two steps that I have shown over here are perfectly mathematically correct. So why is the solution different in these two cases? This is of course correct.
Daham has an answer.
Yes.
The mathematical operation performed in this, both of these are perfectly correct. But
Yes.
the correct should be 122, because as in the BODMAS rule, bracket should be performed first, then other mathematical operations. So that,
Okay, so you are depending on BODMAS.
sir,
And you're saying
BODMAS
that
on all the time.
BODMAS, because you did not use BODMAS in this one, that means you didn't solve the bracket part first. That's why you got the wrong answer. Is BODMAS some kind of god?
Sir, it
Who says,
can be
who says you get this right or you don't get this right? If you obey me, you get it right. If you don't obey me, you get it wrong. I don't agree with BODMAS. I say BODMAS nonsense. I don't like BODMAS.
Yes, sir.
Because he's saying 133 is correct and incorrect and 122 is correct. I don't like that. That's discrimination. Just because 133 is in blue and 122 is in red, blue is wrong and red is right. No, I don't like that. Give me a good reason why it's wrong. I don't see why it's wrong. As far as I can see, both these answers are correct. It should be fine. So if I went wrong, you can't say that it's wrong because the maths teacher said it's wrong. Maths teachers are not gods. Maybe they know something that because of which it is wrong. But they should give me a good logical explanation.
So,
Yeah, who's speaking?
sir,
Tell your name.
Sir Mudit.
Yeah.
Sir, I guess if we do it in different ways, the answers will be also different. Like
Correct.
if first we
first we did it in the board mass way, the answer was 122, and now we are doing it the other way, it's 133.
Yeah, but the thing is that we were clearly told by Nivan, who tried this, that when he got 133, he said clearly that is wrong or something like that. But I didn't understand why clearly it is wrong. You can't say board mass, because board mass is what? It's not, I mean, it's just a rule that we use for convenience in mathematics. We need to understand what exactly this board mass is. As far as I remember, it's brackets of division, multiplication, addition, and then subtraction, which is just saying you have to follow a certain way in which you need to solve problems to get the correct answer. And why should I follow that rule? I don't understand. What is the good reason to follow that rule? There should be a reason why I should follow. That's why I'm saying I don't want to know board mass. Maybe board mass is good once I understand the logic behind it. If I understand the logic behind it, then I know why I'm using board mass. Then it's okay. But without understanding the logic, if I'm just using board mass, then I end up with problems like this. I say this is wrong and that is right, and I don't know why. Okay? Does anybody know incidentally? Of course, there is a reason why this is not the correct solution and this is the correct solution. I hope people are keeping track of time, okay? I don't want to go over my time. So tell me when there's only 5 minutes left. How much time is left incidentally right now?
5 minutes.
10
Huh?
to 9 minutes. 9 to 10 minutes.
9 minutes.
5 minutes. 10 minutes.
9 minutes.
I only want the hump to answer that question because he said he will keep track of time.
It's 10
9
minutes.
minutes.
10 minutes, very good. There's enough time. So okay. We don't need to take up this discussion right now, but you people please think about this. Okay, for some reason you know this is wrong and this is right, but you don't know, or you are not able to explain why this is not the correct solution. Okay, so let us take that up perhaps in the next class. Maybe one of you who has thought about this can lead the discussion. Okay, why this is not the correct solution and this is the correct solution. But without knowing the exact reason or without thinking about the exact reason, I don't want people to say this is wrong and that is correct. All right. So let's that is why this question is important. See, for example, for instance, I picked this question up from, as I have written over there, from UKMT. Okay, it's a junior maths challenge from the United Kingdom Mathematics Trust test. So it's a kind of a nationwide test that is conducted in the UK, and they have it at different levels. So this was a question that was asked in UKMT. Now you may say that, and that is for 10 years old and 11-year-olds. So why is it that they are asking such a simple question? There must be something behind this question which makes us think about mathematics, and that is why they ask that question. Okay, so this is the core of it. We try to figure out why exactly there is one proper solution and why this solution is not correct. Okay, and what should be done? Incidentally, I can ask you this question. I'm sure some of you will be able to answer. What should I do to this in order to get the correct solution?
Sir, Achit.
Just subtract 10.
Subtract 10, just like that. No, I can't subtract 10. I have to subtract
Sir,
what?
Achit. Sir,
Huh?
I know. Sir, Achit, I know.
Give your answer.
Sir, you have to divide it by 2.
Divide what by?
20.
That's what I mean.
You have to divide 22 by 2.
Ah, see? So that's the missing bit over there. You have to also divide 22 by 2. But you know, some people may say, some nitwits like me might say that, hey, you started off with 1 2, now you got 2 2s. That's a problem. Okay.
Answer for this.
But of course, this works out right. If you divide 22 with 2, then over here instead of 22, you get 11.
And 122.
Right? And then you get the correct answer, or you get an answer which agrees with that one. But then again, you have to answer the question, why divide this also by 2? How did I get 2 2s? Yes, tell your name and then speak.
This is Daham and I have an answer.
Yeah.
So, as you can see in the question, 22 and 22 plus 2 is in brackets. 22 plus 2 is in brackets.
22 plus
While
22 is in bracket. 222 plus 22 is in bracket.
22 is in brackets, and divided by 2 is not in brackets.
Yeah.
So while it is in brackets, it is sure. So 2 is sure to be divided by both at the same time, as both of them are concealed from 2.
Concealed from.
2. So like I have an example. Like 2 people are concealed from another person. So both the other person, when it comes to the other 2 people, has to meet both the people at the same time. He cannot meet people different times. He has to meet at the same time. Exactly with this process, this
So that's
2 are divided.
So yeah, I got it. So what you're saying is that is how I look at it. That is how I interpret it. When I see 2 numbers added to one another, placed within a bracket, divided by 2, I am not. This 2 doesn't just associate operationally with this 222 or this 22. This 2 is associating operationally with the whole thing.
Sir, 5 minutes left. Sir.
Right? So yeah, thank you.
Sir, 5 minutes left. Sir.
I got it.
I have one thing to say.
So that's why. May I finish what I'm saying?
Yes.
Yes.
Yeah. So that is why either I can choose to finish this operation first and then divide the whole thing by 2, which would be correct according to our interpretation, or individually perform the divided by 2 operation with both these numbers. Okay, and that's what you do over here. When you do that, then the result agree. Okay, so I think we will move on now from this particular problem. The next thing that I want to share with you people, I'll go back to the Google Classroom, is going to the stream. So over here, I have something called a Sumaze for parallelogram. Did you people see where it is? So if you go into Classroom, you'll see it in the stream. Okay, so I have put a link for that. And when you click on this, you go into a website, integralmaths.org. And in this, let me finish because there isn't much time. I have to finish this. After I finish talking about this, then people can tell me. Okay. So some people were asking me what to do over here. So this is a game, okay, where you have to get this number over here, the blue tile, to the goal. Okay. So how do you do that? There are mathematical operations that are there in the way. So, and then there are arrows that are given over here. So this is just an instruction. The moment you click on this, the instructions will go away. Okay. So you can see the one move down here, and then you move one more down. 1 plus 2 becomes 3. Okay. Then come down, 3 minus 1, that will become 2. Come down again, 2 times 3 will become 6, and 6 reaches the goal. So that is your task done. And you may say that, how silly. That was so simple.
Sir,
Yeah.
can I tell something? Sir, instead of pressing the top, right, left, and bottom buttons, you can just use the keys. You can use the keys.
You can also use the keyboard. Yes, I was just showing that.
Sir,
Thank you.
first you have to follow the instructions. You have to see the instructions, and then only you can.
Correct. So I'm just sharing this. Okay, Srivas, I'm just sharing the instructions myself directly with students who may find it difficult. Okay. So now you can see over here there is a 5, that is the blue tile, that's me, and the green tile is giving a condition. It should be equal to 6 for you to pass this. So you can see if I try to pass this, I keep pressing the down button, but it will not work. Okay, because 5 has to turn into 6. So how will 5 turn into 6? Well, if you add 1 to it, it turns into 6. And then it satisfies the condition and you are able to reach the goal. Okay. And as you go from one task to another, the tasks will become slightly more difficult. Okay. And sometimes there are multiple possibilities that are there. So you have to kind of figure it out. Like say for example, if I do this, it becomes 3, and if I do 3 times 2, it becomes 6, and then I can't go forward. So I'm stuck. So what I should do is I should restart the room, and then I start the task again. Okay. So you are
Sir,
you
you
will
should do 2 into 2, sir. After
Are
that,
genius? Oh. Had your say? Thank you. So what you have to do is, I'm just saying in case you make a mistake, what you should do. You can restart the whole game. Okay, so then you use the correct solution and reach the goal. There are 10 such tasks if I'm not mistaken. And at the end of the task, you will get a score out of 45. If you don't mind, you can, after you completed the game, please post the score that you got uh, on the Google Classroom. You can send it directly to me as a comment. Is that fine? If you want to. If you don't, you want to keep it to yourself, or you want to share with me privately, just send me an email. And if you don't want to share it with me, that's also fine with me. Is that all right? Okay, so now it's time. We will stop here. The whole thing comes from something called a parallelogram. I will talk about parallelogram in the next class. Those who have already found out the parallelogram, you can try some tasks from that. That is also from a very interesting author from the UK. But I will talk about him in the next class. Okay? Shall we stop now over here?
Yes, sir.
yes, sir.
Yeah, if anybody wants to ask anything, I can be here for a couple of minutes, so you can ask me.